All right. Our next speakers. Yes. I think we're a little bit ahead of schedule, so you're coming off the clock. So we're a little bit behind schedule. We will get there. Just 20 minutes, not a big deal. But we've got someone from the presentation. Give me a second. Here we go. So we've got David Cameron and Gregor from the DEXPI group, and they've got something to share with the CAPE-OPEN community. So please take it away.
So I will start for 1 to, 5 minutes. I will give a high-level introduction for those who have never heard of DEXPI. What is DEXPI? Why are we doing things like data exchange in the process industry? And then David will give you an update to the presentation he had last year so that you have an idea of the progress that we did in the meantime. So my part is why DEXPI and why are we trying to cooperate with CAPE-OPEN or CO-Lan? So DEXPI is for data exchange in the process industry. It's not saying process simulation, interoperability on runtime. So it's not the same as what CO-Lan is doing, but DEXPI is an association as well. And DEXPI is about interchanging information or combining, integrating information. And DEXPI has, let's say, a wider scope. It's not just simulation, as I already said. This is kind of the DEXPI problem statement tailored for this community. So we are looking at process flow diagrams, PFDs, and assume you have a very smart PFD tool on the one hand, and there's another smart tool that you want to use for your further engineering workflows. And both are intelligent, both are smart, but in the end, you somehow have to deliver all the data that you have in one tool to the next one to continue working with it. And DEXPI is about enabling this. DEXPI is about how to describe a process flow diagram that you can use for example, as a topology for flow sheet simulation, and how you can serialize the data that is contained in a format that can be consumed by another tool, by the next tool. And by another smart PFD tool, we include flow sheet simulation. So you could start with an engineering software drawing your PFD or your block flow diagram. We already saw PFDs and BFDs in previous presentations. You start with your drawing software, you save as DEXPI PFD file, and use this file to initiate your flow sheet. And you have all the unit operation and streams already predefined. You just have to fill in the code to calculate this. So this is what we look at from the DEXPI perspective. DEXPI is an association. We have 10 to 20 full-paying members. We were founded last year in October, so we are 1 year old. And we are, okay, we have a history, of course. And so far we focus on the P&ID, so the later diagrams in the engineering lifecycle. But now we continue to go to direction of process, where we have the PFDs as well. And this is where we want to start an MOU or cooperation to look together with CO-Lan how to enable customers to have simulation combined with PFD tools and P&ID tools to cover more of its whole life cycle using digital tools. And that's for my part. And I hand over to David, who will give you an update of what he already started last year.
Okay, and so to motivate discussion, I discovered something lurking on my hard disk, which was something called ISO 1033221 2007, which was trying to describe how we do process engineering. So this diagram from hell is what we're trying to avoid by using DEXPI, where you have layers upon layers of documents flying in all directions in your project. So a lot of the slides from this were actually taken from last year, because last year I gave a presentation on what DEXPI process was, and then came with some questions around CAPE-OPEN. What has happened since then is that a couple of people involved in process simulation have been working on prototyping around trying to see whether simulators can interact with DEXPI process. There's some results on the way there which are actually quite positive. The people doing it are Aveva and DWSim at the moment. Now, the lessons which are following up from Gregor's comment is that DEXPI is data model, not just the data exchange format. He started off with saying we need to do data exchange for P&IDs. What we see is the thing that's more interesting for engineering companies is actually we need to be able to have a good data model for the plant. And so I've got my drawing from hell, which shows complicated structures. But what I'm trying to show here is that DEXPI process, which is the standard for describing processes, and the old P&ID model, which is now being branded as DEXPI plant, give you the way of defining a topological link together, a topological model of your process design and your plant design that you can link together, and that you can move through the phases of process design from concept through to actually putting on the maintenance functionality you want on the equipment, using the classes in DEXPI process, and then use the classes in DEXPI plant to create your plant model. So we have these two models that then provide a basis for consistently managing the data. Now, the point with DEXPI, this modeling, is that those models should be other things that contextualize all your data. What you're doing in engineering is all those data sets that were flying around on the previous diagram I showed you now can become data sets that are referenced to objects in that model. And in the design process, you have your process requirements. They will then stimulate a lot of steady state simulation cases that now suffer this fate. Your requirements, and I showed this last year, that you take your requirements, you create a manual structure and a configuration model from your PFD. You then take the specifications, perhaps throw them into an Excel file, then turn the handle on the simulator, and then the simulator has its own proprietary tool to throw those results back out into Excel, and then your cases are then carried onwards by whatever manual approach you have to put it into your engineering system. Now, DEXPI and CAPE-OPEN are actually also very complementary. So this is a fairly academic way of looking at a system that's based on what's called aspect modeling, which was something which came out of the OntoCAPE project back in the 1990s, Wolfgang Marquardt's group in Aachen. And this is, we look at a system in three ways. The first way you look at it is, what does it do? That's your process design. That's where DEXPI process helps you with that. Then the next question you have, the other aspect is, well, what is the plant? What equipment do you have there? And that's where DEXPI plant, the P&ID model, is actually the thing that structures your information. But then the next question then is, well, what does a plant do? Actually, how does it behave? And that's where simulation comes in. And that's where CAPE-OPEN is, about linking the process simulation and the thermodynamic properties to the process structure and the plant structure that you have. Now, DEXPI process is not rocket science in a very it's not a very complicated model. It's basically blocks with ports with connections between them. Sounds very familiar to simulation and to CAPE-OPEN. And we deliberately took the best out of various process modeling standards, SysML and CAPE-OPEN. And there was a lot of background from people who've been heavily involved in simulators like Gregor and me into actually structuring the model. So what we have is a structural model consisting of process steps, read unit operations, with streams connecting those ports. What we also need to do on PFD modeling is to model flexible stream table. And so what we did in DEXPI process is to build up a way of defining a stream structure for groups of thermodynamic streams based on a concept which is familiar to CAPE-OPEN, a material template, which then says what components are in that, and then you can additionally put in information about what thermodynamic methods you're going to use as a potential extension. And then you have an material state object that you configure to receive the data out of the stream table. So that's very flexible. It has multiple phases, and you can create a simple stream table or a very complicated multi-phase stream table using that structure. Then we need some sort of reference data about process steps. And so what DEXPI process at the moment proposes is a set of process steps, again, based on existing standards, that we believe cover large amounts of the process industry. That assumption needs to be validated. So we need help from companies who have their own libraries of unit operations to see where we need to supplement the reference data we have for unit operations. So again, the slide from last year. We can use DEXPI process files to store design cases. So the first thing we do is we define a structural model, which is a data set which says, I've got these unit operations, they are connected together like this. That then enables you to create similar files that just contain data. And the first set of data sets you can have is actually data sets which contain constraints. And they can be used to define simulation cases. And then you can turn the handle, hopefully on a simulator, and create data sets containing results, which are the behavior sets. Now, this is what you do generally in design now, except that your structure is a drawing, and there aren't very many smart PFD tools. And your characterizations or specifications are usually documents or Excel sheets, and your results now are usually Excel. So, how can we interact with the simulator? Last year, I had a big no entry sign on the ability to use structure and specifications. Progress this year is there's now a question mark there, which we see that there is possible to read information between certain types of simulators and what we're doing. We still see that there's a substantial opportunity to make the flowsheet monitoring interface talk DEXPI process. That would be a fairly low-hanging fruit in the collaboration we're doing. And the monitoring interface is there, and we've got information again from last year. We have these mappings at present between different DEXPI process structures and CAPE-OPEN objects. So our friend the process step and to a certain extent the process step detail relate to unit operation, port supports, and then the stream energy flow information flow map across to the material stream energy stream and information stream in CAPE-OPEN. So this is again from last year and things which need to be addressed if you're thinking about how we relate stack process information simulation. Every process simulator has a certain set of unit operations with their own local syntax. So you need to do a mapping between our process step types and unit operations in the simulator. We need to map ports and we need to map parameters. If you do that, you're then in a situation to be able to get information out of the simulators into the format you want, and you could have the possibility to also then push specifications as case definitions into a simulator. We also see the opportunity here that you can use DEXPI process structures as documentation for your thermodynamic data and project, the project basis you make for defining your thermodynamic models and data. We haven't got terribly much information about that, but I would propose that we can extend the DEXPI process standard to contain static specification data around thermodynamic properties. They'll be valuable for us. And we then have the mechanisms there to do some mapping across to your simulators. And what we would wish to do is challenge the simulator vendors to provide an export format in DEXPI process so that we can kill the Excel tools we have now. That's my ambition. I've spent 20 years trying to kill Excel and I've never failed, never succeeded. So that's status. We haven't really come very far from last year, but there's some good results with some people doing some prototyping, which is very promising. I'd like to open a bit for discussion about how and where you can see that we can actually link these two things together.
Presentation is now open for questions. That's good.
You already pointed out that in the direction from existing flowsheet simulation to DEXPI case, flowsheet monitoring is the way to go. Make sure that all the unit operations are exposed there. DEXPI vocabulary. I'm a pump. I'm having this and this function,
yeah,
and a flowsheet monitor on top. This is an excellent business case to get the simulation vendors to implement support for flowsheet monitoring, because that will be a difficult step. This is always the difficult step in CAPE-OPEN, to get support from the software vendor.
Mm-hmm. Would you see that flowsheet monitoring would be the best way to? I could see that our friends, the software vendors, would say, "Okay, we'll just hack a script to
short of a function that only does DEXPI, I would say, yeah. Flowsheet monitoring gives you access to all the streams, all the unit operations, and anything you want to query from there, and the flux here between them, which is the information that's in the overall picture."
Did you miss anything in the monitoring interfaces which you would like to have, except for more the semantic type of unit object? DEXPI could take over.
I think we'll have to ask the people who've been doing the implementation work. I haven't got my fingers dirty on that, so I can't make an assessment about that. But
just a question. There is a very annoying task when we design to capture facilities we feel that would change the or so on the street. Is your tool able to make a sort of structure that we can change and the optimal configuration and then print out what is the optimal conditions?
I didn't follow the first paragraph of what you said.
Can I use your tool as optimization superstructure? So extract data, run the optimization, and then input the data inside the process simulator.
We don't have a tool at the moment. The issue is we have a data exchange standard. And so, yes, if you have a superstructure that you want to define your optimization around, you can say, I want to get these parameters regarding this process, take it up into your tool, and then write it back using the same format. That's part of the idea, that what we're doing in DEXPI processes enable you to actually isolate the process design so that you can talk about process constraints. It's one of the other challenges we see when you're actually doing documentation of facilities, is that a lot of your process design information is actually rolled down into your equipment design. And so the experience of doing process troubleshooting is usually going into the archive to try to extract your process rationale from the detailed documentation you have of your equipment design, especially in existing plants. So the idea is, if you have a first-class citizen process model, process optimization and troubleshooting will actually be easier because you've got those process constraints and requirements documented clearly there with good traceability down to your plant line.
That would be something where the monitoring interfaces needs to be extended. Also, we want to change the structure of the model. Adding and removing units, streams.
That will be on the flow sheet synthesis side.
Yeah.
Which is, with the initial iteration of flow sheet monitoring, we wanted to stay away from that. Because it is much more difficult to get software vendors to implement support for that.
But I think some sort of, we could stimulate competitive advantage in the simulator market by saying that we will support auto configuration based on a process design with our simulator. And okay, if the legacy simulator vendors don't want to do that, you'll find a situation where people are using COCO.
Well, there are situations, of course, in which they say we can do that, but we need to use our proprietary interface.
Okay.
So you said DEXPI is a data model.
Yeah.
And I understood that you need to transfer the data along the process. So let's say from a block diagram to a PFD to a simulation to a PNID. So you want to carry over the information along this chain. So this is, let's say, making sure that the compatibility between these different tools is made clear.
Yeah.
And then you have the other part. If you have a process simulator, for example, and the first process simulator reads in the DEXPI format, and the second process simulator reads it in, and third one, and so on. Have you made sure that the data model is really consistent between all these different tools already?
Oh, no.
And
absolutely, yes, absolutely.
how do we achieve this?
It requires a mapping per simulator. To say, and that's where we need to actually get some access to some good cases. And what we've seen, there's some preliminary results which will be coming in about a month from DWSM, saying that yes, the data models are consistent, that you can take a DEXPI model and implement it in DWSM. Now, also, the ability in DEXPI to define a material template is the place where you get consistency in your stream data model. Because that is the way where you in your project say that I'm going to represent my hydrocarbons with these components and these pseudo components with these properties. And so that is where you build your stream table compatibility with the simulator. Now, I know enough about simulators to see that they've basically got the same semantics in the bottom. So it's a one-time mapping for the unit operations.
Yeah, hopefully.
Yeah.
On the other hand, what I can imagine, and maybe playing devil's advocate a little bit, but you propose a data model, let's say, and you compare it with the ontology that is used within the first process simulator, and you match. Okay, yeah, we have a 1-by-1 match, so we can translate from DEXPI to the simulator and from the simulator back to DEXPI data model. Then you try to apply it for the second process simulator, and then you find out, oh, it's not by 1-by-1 translation possible. So we need to either extend the data model, but then you need to return to the first process simulator data model and say, we need to be compatible with the second one too. So we change the data model, and is it still compatible with the first one? Can we get a catch-22 situation by that?
Oh, I'd try to postpone that particular problem until it's actually encountered. What we're trying to do here is to create a standards-based standard for describing process design data. So we've done a lot of work around using existing standards. Given my simulator industry experience and use of simulators, I can't see the ontological problem that you're going to have there.
Okay.
Also, in the midterm, We want to be more present as a good or best practice in universities. That DEXPI is more known to have a more systematic or standardized approach. And when you have a publication, then you can say, okay, I can deliver the DEXPI flow sheet accordingly, having everything classified using this reference data library. And in addition, here we can have the model equations. So we can deliver more in a standardized way. That is the academic nice point of this.
But as a sanity check, to try to map a VT plan would be an interesting and not very time-consuming exercise.
We're gonna have to stop the conversation maybe because we have a couple of minutes, and it sounds like there's some more interesting discussions that will happen over lunch. But I think if we can thank the DEXPI group for the